Now we're next going to take what we just learned about what an identity is and use it in the context of solving a system of linear equations. So the example we have is the following. We have the system consisting of negative x minus 3y is equal to 7 and 4x plus 12y equals negative 28. And we're going to solve this using the substitution method. And I think you'll probably agree with me it's going to be easiest to take the first equation and solve it for x. So let's do that down below here. So if we add 3y to each side, we're going to have negative x is equal to 3y plus 7. If we multiply each term then by negative 1, we have x is equal to negative 3y minus 7. And what we'll do next now, substitute that for x into the second equation. So we then have 4 times the quantity negative 3y minus 7 plus 12y is equal to negative 28. And if we distribute here, we'll have the negative 12y minus 28 plus 12y is equal to negative 28. And I think you can see that adding the y terms, they will cancel, and we're left then with negative 28 is equal to negative 28. So the variable terms have dropped out completely, and we're left with a true statement, which means the equation we were working with above is an identity. So that will tell us that there are indeed infinitely many solutions to the system that we have here. Now remember what that means though. That will tell us that the graphs of the two equations actually turn out to be the same line. So the lines coincide. So in this case, you recall that we need to express the solution using set builder notation. And we do it in the following way. We're going to say that it's a set of all ordered pairs xy such that, and we'll name one of the equations in the system, and I'll choose to name the first equation, so negative x minus 3y is equal to 7. Now remember what that's saying. It's telling us that we want all the points that lie on the line negative x minus 3y equals 7. Now to confirm that indeed the two lines are the same, we'll graph them both, and that we'll do next. Now to confirm that the graphs of both equations in the system are the same, what we'll do is put each in slope-intercept form. So the first equation I've highlighted in blue, and if you solve it for y, I think you can see that you'll end up with y being equal to negative 1/3 x minus 7/3. In solving the second equation, which I've highlighted in red here, we end up with the same, which is negative 1/3 x minus 7/3. And so graphing the two equations, they turn out to be the same line, so they coincide. So therefore, there are infinitely many solutions to this system. Now, do you remember what the name of the system is or how we can describe it? Remember the two words that we can use here in this context. We'll say that this system is dependent and the other word that we can use as a descriptor here, consistent.